Hello students, good morning and welcome to another video lecture of physics. Now in last few video lectures we were discussing about Biot-Savart law. We have derived formula for a straight current carrying wire using Biot-Savart law, right? Both the cases we have discussed, one was for the finite length, wire of finite length, while the other one was related to wire of infinite length. Here you should remember that the formula which we have derived, that derivation is not in your syllabus. In fact, the magnetic field produced by a straight current carrying wire of finite length is not in our syllabus. Yet that concept is important for your entrance exam, and that's why we have derived that formula. So no need to prepare or derive that formula. Just you have to remember the formula for the magnetic field due to a current carrying straight wire of finite length as well as of infinite length. Right, infinite length of course we are going to derive by using Ampere's circular law. So those two formulas just you have to remember for competitive exams. Then we have discussed about magnetic field produced by the current carrying circular loop of certain radius along the axis of the loop. That is, we have derived the formula for magnetic field for the ring along the axis of the ring. Right, this was the figure which we have discussed in our last video lecture. Now here magnetic field produced at point P due to this current carrying ring is given by, if you remember, we have derived formula B is equal to mu naught I a square over 2 x square plus a square whole raised to 3 by 2. This was the formula for the magnetic field produced by a current carrying ring. Now in this ring, if there are n number of turns, so for n number of turns, now here ring will have obviously one turn, so you can say that we have a helical coil. This is one turn, then second, third, fourth. Suppose we have 5 turns, right? So in that case magnetic field for one turn is mu naught I a square over 2 x square plus a square whole raised to 3 by 2. So for 5 such ring it will be 5 times of this, so that will be equal to mu naught into number of turns, mu naught n I a square over 2 x square plus a square whole raised to 3 by 2. Mu naught n I a square over 2 x square plus a square whole raised to 3 by 2. This is the standard formula which you should remember, right? This is along the axis. We have already written B of axis, and here also B of axis along the ring. Now let us discuss special case, or in fact special cases. There are two cases, right? Number one, magnetic field at the center of the ring. Magnetic field at center of ring. Magnetic field at the center of the ring. Suppose this is point P, which is at a distance x from the center. Now if you move this point towards the ring, x will decrease. If you move this point towards the ring, suppose P is here, then x will decrease. And at the center of ring, that is, if point P is taken at point O, then magnetic field will be, in that case x is 0. You can see that if we take P point at point O, x will be 0. Right, so in that case magnetic field at the center of ring, for magnetic field for B, that is magnetic field at the center of ring, x is 0. Magnetic field at the center of ring, for that case you should take x equal to 0. So in this equation you can write, therefore B at center will be equal to mu naught n I a square over 2 into x is 0, so a square raised to 3 by 2. A square raised to 3 by 2. So here 2 and 1 by 2 will get cancelled out. So therefore B of center will be equal to, B of center will be equal to, let me write here, therefore B center will be equal to mu naught n I a square over 2a cube, 2a cube, right? So obviously a square and here a square will get cancelled out. So therefore magnetic field at the center of ring will be equal to mu naught Ni over 2a, and this is the most important equation. Most of the MCQs or sums for ring will be based on this formula, that is B of center equal to mu naught Ni over 2a. Clear? Now the second case is for x much more greater than a, means this point P is at very large distance such that radius of ring can be neglected, right? So in that case, for x much more greater than a, that is point P is at very large distance from the center of the ring, so that radius of ring, that is a, can be neglected. So for x much more greater than a, B will be equal to mu naught Ni a square over 2 x square raised to 3 by 2. 2 will get cancelled out. Here x is much more greater than a, then you can neglect a in comparison with x. We cannot neglect a over here because it is in multiplication. So here, whenever, suppose if you want to neglect something, either it should be in addition or it should be in difference, then only you can neglect those things. Suppose if it is 1000 plus 0.001, then you can easily neglect 0.001. But 1000 into 0.001, we cannot say that since 0.001 is very small, let us neglect that. So answer is 1000. That is incorrect, right? So in addition and subtraction you can neglect, and that's why here we are not going to neglect a. A should be neglected over here in addition with x square, with respect to x square. So here squares and square root will get cancelled out. So your answer will be B will be equal to mu naught Ni a square over 2x cube, right? This is the another formula. Okay, so do one thing, pause this video and fast copy this. So the magnetic field produced by a current carrying circular loop is given by B is equal to mu naught Ni a square over 2 x square plus a square whole raised to 3 by 2. This is the formula for magnetic field produced by a current carrying circular ring or a loop, right? Based on this B, let us say this is B of axis, B of center, magnetic field produced at the center of a current carrying ring is given as mu naught Ni over 2a, mu naught Ni over 2a. And third is B is equal to mu naught Ni a square over 2x cube. This is for x much more greater than a, right? These are the three formulas which we have derived. Now one more important concept related to entrance exam is, let us say this is for JEE, NEET or good set. Suppose we will take ratio of B of axis to B of center. Let us take ratio of B of axis to that of B of center. So that will be equal to, now B of axis is mu naught Ni a square over 2 x square plus a square raised to 3 by 2 whole over mu naught Ni over 2a. So you can see that mu naught Ni will get cancelled out, 2 and 2 will get cancelled out. So therefore B of axis over B of center, therefore B of axis over B of center will be, this a will move up, right? So a cube over x square plus a square whole raised to 3 by 2, a cube over x square plus a square whole raised to 3 by 2. You can do one more thing, look, a square raised to 3 by 2 I can do writing, right? Multiplying or squaring and taking square root of this thing, a square 2 will get cancelled out, that is a cube. So a square whole raised to 3 by 2 over x square plus a square raised to 3 by 2, powers are same, right? So you can write this as a square over x square plus a square whole raised to 3 by 2. or if you rearrange this, then this implies that B of center over B of axis will be equal to x square plus a square whole upon a square whole raised to 3 by 2, or you can write x square by a square plus 1, because a square by a square will be 1 whole raised to 3 by 2. This will be the formula, and this is the important formula, right? Based on this we do have some MCQs for your entrance exam. You will find many MCQs in Yogi or Darpan based on this concept. Clear? So again, pause this video and copy this. We are going to solve examples based on this concept. Okay. So the ratio of magnetic field produced at the center B of center to B of axis is actually given as x square over a square plus 1 whole raised to 3 by 2. So based on this, MCQs can be asked like at what distance along the axis of the ring, at what distance along the axis of the current carrying ring magnetic field produced at the center is 27 times magnetic field along the axis. At what distance along the axis of a current carrying ring, the exact question will be something like this: at what distance along the axis of the current carrying ring the magnetic field produced at the center is 27 times the magnetic field along the axis, right? Nothing else is given. So you can say that given B of center is 27 times B of axis. Take this in denominator or on the other side. So therefore you can say that B of center over B of axis is 27. Now we will directly use this formula. We know that B of center over B of axis is x square over a square plus 1 whole raised to 3 by 2, and that is given as 27. Right, this is 27. Right, now we want to remove this cube, so we'll take cube root. Right, so if you take cube root, you will get x square by a square plus 1 whole raised to 1 by 2 is cube root of 27 is 3 3s are 9 3s are 27, so that will be 3. Now we want to remove this square root, so squaring above equation. So if you square above equation, you will get x square by a square plus 1 is 9. X square by a square plus 1 is 9, or this implies that x square by a square is equal to 8, or x square will be 8 times a square, or x is equal to root 8 times a square, or simply you can say that x is equal to 2 root 2 a square. This will be the, a. Here it is a, 2 root 2 a, right? So this will be the answer for the given question. So instead of 27, if something is given, look here 27 is there, so that is 3 3s are 9 3s are 27. So what you have to do, you have to split 27 into 3. 3 3 3 3 3s are 9 3s are 27, right? And out of this you have to multiply these two, so 3 3s are 9 minus 1, that is 8, so you are getting here root 8. B of x will be equal to root 8 times a, right? Instead of 27, if it is 81, or let us say 64, if it is 64, then 4 4s are 16, 4s are 64. You have to take 2 4, 4 4s are 16 minus 1, so it will be I think 15 times, or the answer will be root 15 times a. X will be equal to root 15 times a. So what you have to do, you have to take cube root of this, then square it. Cube root of this, then square it and take 1 minus from this, subtract 1 from this, then root of that will be your answer. Look, here it is 27. So cube root of 27 is 3, and square of 3 is 9. 9 minus 1, 8. So root 8, right? Root 8. So this is how you can easily remember how to find. Clear? So do one thing, pause this video and copy this. Now we are going to solve examples from our textbook based on this concept. Now we are going to solve examples based on the topic which we have discussed right now, that is magnetic field produced by a current carrying circular loop, maybe at its center or along the axis, something like that. Now you may have some confusion based on the direction. So the next video lecture, that is will be uploaded on Tuesday, right? So on that, in that video lecture we are going to discuss about how to find direction for a straight current carrying wire. In fact, we have discussed in our previous videos, but again we will discuss how to find a direction of magnetic field due to a current carrying straight wire, as well as the direction of magnetic field for a current carrying circular loop. Both this concept we will discuss in that video lecture. Along with that, as I have said, we are going to solve examples which were given to you as your homework, that is magnetic field at the center of a square, rectangle, triangle, hexagon, right, and two semi-infinite, actually 4 semi-infinite wires arranged in a particular manner, and we have to find magnetic field at some point P. So all those topics we are going to discuss in our coming video lecture, right, that is on Tuesday. In this video lecture we are going to solve, so next what we are going to solve is example 4.7. Example 4.7. Consider a tightly wound 100-turn coil of radius 10 cm. A coil which is having 100 turns. So number of turns N is given as 100 and radius is given as 10 cm. So that is actually, you can write 0.1 meter. Radius is 0.1 meter. Carrying a current of 1 ampere, the current flowing through it, I, is given as 1 ampere. Current flowing through the coil is given as 1 ampere. What is the magnitude of the magnetic field at the center of the coil? We want to find magnetic field at the center. What is the magnitude of the magnetic field at the center of the coil? So B of center. Look, directly you have to put the formula and simplify. Quite simple one. Can be asked only for 2 marks, right? B of center is equal to mu naught Ni over 2A. B is equal to mu naught Ni over 2A for the center of the ring. What is mu naught? 4 pi into 10 to the power minus 7 into N is 100, I is 1 over 2 into A is 0.1. 2 2s are 4. So 2 into pi is 3.14 into 10 to the power minus 7 into 100, 0.1. 1 divided by 0.1 is 10. So 2 into 3.14, 2 3s are 6 and 2 1s are 2, 2 4s are 8. So 6.28 into 10 to the power 1, 2 and 3, 10 to the power 3 and 10 to the power minus 7. So this will be 10 to the power minus 4 Tesla. So magnetic field produced at the center of this ring is 6.28 into 10 to the power minus 4 Tesla, right, and that is the answer. The next example based on this concept is from our exercise, that is exercise 4.1. Exercise 4.1. A circular coil of wire having 100 turns. Number of turns in it is given as again 100 and is 100. Each of radius 8 centimeter. Radius of each turn, that is A, is given as 8 centimeter. So you can write this as 8 into 10 to the power minus 2 meter. Radius is given as 8 centimeter. Carries a current of 0.40 ampere. Current flowing through it, I, is given as 0.4 ampere or 0.40 ampere, you can write. What is the magnitude of the magnetic field B at the center of the coil? Exactly similar to this, we have to find B of center. So here magnetic field produced at the center of the coil is mu naught Ni over 2A. Actually you can write, we know that magnetic field produced at the center of a current carrying circular loop is like this, right? So that is equal to 4 pi into 10 to the power minus 7, N is given as 100 into 0.4 is 4 into 10 to the power minus 1 over 2 into A is 8 into 10 to the power minus 2, right? So 2 2s are 4, 4 2s are 8, and this 8, so 2 2 and this 4 will get cancelled out. So this will be equal to pi is 3.14 into 10 to the power, look, minus 2 will move up, so plus 2, this is 100, so plus 4 minus 8 is 10 to the power minus 4 Tesla. Minus 7 minus 1 is minus 8, minus 8 plus 2 is minus 6, minus 6 into 10 to the power 2, so minus 6 plus 2 is 10 to the power minus 4. So answer will be 3.14 into 10 to the power minus 4 Tesla. Clear? Again pause this and copy this. Now at the end of this video lecture, we are going to discuss a small yet an important concept for entrance exam. In fact, for your board exam also and good set also. Suppose a ring is given, let us say we have a ring of radius A, and it is carrying current I, right? If this ring is bent in such a way that there are n number of turns, right? Suppose right now the ring will have only one turn. Now if this ring is bent in such a way that it has n number of turns, right? So the same ring, if it is bent in number of turns, then obviously you will find that its radius should decrease. So what will be the new magnetic field? For a given ring, for this ring having one turn, magnetic field is B, its radius is A and current flowing through it is I. If it is not given, then also we will assume that radius is A and current flowing through it is I. Let us say this is the direction of current. Now if this is the direction of current, magnetic field will be, what you have to do, you have to rotate your palm in the direction of current. So this will be the direction of magnetic field, which is perpendicular to the plane of the board and coming out. Of course, we are going to discuss this in the next video lecture. So here, what will be new radius? Let us say new radius is A dash. You should remember that length of both the rings, that is L1, let us say for first ring, will be equal to length of second ring. Length of first ring will be equal to length of the second ring. Obviously wire is of the same length, right? If you have a straight wire and you are making one loop, its radius will be very large. But if you are making two loops, then its radius will decrease. If you are taking three loops, then even radius will decrease. So here length will be same. So length of a circle is 2 pi A, 2 pi r is the circumference, that is the length. And here there are n number of turns. So n into 2 pi A dash. So here 2 pi will get cancelled out. So A dash, new radius will be A by n. So if there are 2 turns, radius will become half. If there are 3 turns, radius will become 1/3 and so on. So A dash will be equal to A by n. Now B at center, we know that magnetic field at the center is given as mu naught Ni over 2A. So therefore for first ring, therefore B1 for the first ring will be mu naught I over 2A, because in this case n is 1. We have considered n as 1, having only one loop, right? Now what will be B2 second loop? This one is mu naught, number of turns are Ni over 2A dash. So that is equal to mu naught Ni over 2. What is A dash? A by n, right? So this n will move up, so this will be equal to mu naught I over 2A into n is n square, or therefore you can say that B2 will be n square times B1. B2 will be n square times B1. It is given something like this. Suppose you have a current carrying loop such that the magnetic field produced at the center is, let us say, 4 Tesla. Now if the loop is bent in such a way that it has 2 turns, then what will be the new magnetic field at its center? Then the new magnetic field will be 2 square times B1. So that is 4 times 4. So 4 4s are 16. Magnetic field will become 16, right? It will become 4 times. If number of turns are 7, then 7 square times B1. Right? So this is how you should remember. Clear? So this is it for this video lecture. This all are most important concept which is not given in our textbook, right? NCERT textbook. Yet you will find this kind of MCQs in your good set papers, old papers, even in your board exam also this kind of MCQs were asked, right, the old syllabus. So you have to prepare MCQs related to this all concept which we have discussed. So this is your most important video lecture for your entrance exam or for MCQs. Clear? Thank you. Let me rotate this camera. Okay, fine. Now you can see and copy.